Hi, good evening and good morning, everyone. Welcome to today's webinar. My name is Fang Fang. I'm VP Events for Alberta AI Association. It's my honor to be It's my honor to be hosting the webinar given by Dr. Yuxi Li. For those of the audience who regularly attend our event, you already know this event is held monthly, aiming to sharing the research achievements and advances of AI technology contributed by our speakers and their work. And this event is co-organized by CNKI China and Alberta AI. To know more AI events and programs organized by Alberta AI Association, please visit our website, albertaai.org. Now, please let me introduce today's speaker, Dr. Li Yuxi. Dr. Li received his PhD degree in computer science from University of Alberta. On reinforcement learning for real life, he's the lead guest editor twice for the Machine Learning Journal special issue. The lead co-chair for ICML 2019-2021 workshops. He also authored a 150-page deep reinforcement learning overview with more than 800 citations. He has published papers at NeurIPS, AIST, ATS, and InfoComp. He serves as reviewers for AAAI 2019-2022, ACM Computing Service Communications of ACM, PAMI, TKDD, and the PLOS1. He founded an AI company named Attend.ai in Canada. So today, Dr. Li will give a talk about reinforcement learning, artificial intelligence, metaverse, and applications, which is really a hot topic nowadays. The lecture will take 1 hour, first about 45 minutes speech, and then 15 minutes Q&A session. You can ask questions under discussion section, either during presentation or after, and Dr. Li will answer them after the speech. So now let's welcome Dr. Li to give his presentation. So Dr. Li, please take it over and start your work. Thank you.
Okay, yes, thanks Fang Fang for the introduction, and thanks for AlbertaAI and CNKI for the invitation. It's my pleasure to share my understanding about reinforcement learning AI and Metaverse with you. Actually, the content will be a lot. You may see that there are 126 pages slides of this talk, but so for many slides I'll go over very fast. But at the end there will be a discussion Q&A. So if you are interested in some topics, we can talk more at that time. Okay. Yeah. So first, let's may peace prevail on earth. Hopefully, we live in a peaceful world. So everybody knows AlphaGo is in 2016. Actually, it's a work done by many people from Alberta. So to be a graduate from Alberta, I feel very proud of this. And the underlying technique is reinforcement learning. Reinforcement learning is basically about an agent interact with the environment and their state, action, reward. And this is a very abstract model. It can represent many things, many applications in the real life scenarios. And this reinforcement learning is actually related to many fields, many disciplines. We can see this during our talk. And I also put some high-level categorization of those concepts: deep learning, reinforcement learning, super learning, algebra learning, deep learning, and say on the left is machine learning, on the right is about AI. So basically, deep learning is part of machine learning. Machine learning usually we say machine learning has supervised learning, actual learning, and reinforcement learning. Machine learning is part of AI. Yeah, this is a very brief introduction of this, very huge field. So there are some very strong hypotheses that reinforcement learning and deep learning can together achieve AI, or say something called artificial general intelligence. This is actually from David Silver. David Silver was a PhD, got his PhD from Alberta, and he is the first author of AlphaGo. But this is a hypothesis, so there are some arguments about whether this is correct or not. But that's academics, right? So we discuss things, and there may be debate. Another strong statement from say David Silver and others is that reward is enough. The hypothesis basically it says that when we have some goal, for example, for the robot, he want to say cook meal, and with this goal, he can build his skill gradually, and finally he can achieve this goal. Okay, that's a very, very brief introduction to reinforcement learning. Basically, it says it can do many things. And next, I will talk very briefly to Metaverse. Yeah, Metaverse. I think many of you have. I believe you have already read lots of things about Metaverse. And for me, my summary is something like it will be the future of personal computer, internet, and mobile communication. And it will also be the future of simulation and digital twin. And it is based on many techniques, like say VR, AR, MR, like AI, like cloud computing, like 3D, like 5G, like blockchain. Actually, it's kind of like blood monks discussing about the elephant. This is a very old story. And think, Metaverse is a so huge a concept, and it may be pursued by many people in different ways. So for me, I look at it more from the AI machine learning way. And Metaverse, one thing ignited Metaverse is the Roblox, the company, the IPO of this company, and Roblox identify 8 elements, and basically after the IPO, many people start discussing about this concept, and later Facebook changed the name to Meta and another wave. But now say this company, the stock market, you can see it's not so good right now. So we need to at least this is a concern. We need to think about whether there are something wrong, or is this promising or something. But at least the stock market is not so good for this Roblox, the first IPO company for this Metaverse concept. So Metaverse, for many people, it's about social network. It's about like say NFT, like say blockchain, those kind of things. For me, I just like as I just now. I look at it more from the way of AI, and also from the science and technology part. And so there's something called industry metaverse. So the simulation and reality can meet using this kind of metaverse, and then AI, big data, those techniques can help improve the productivity for this industrial metaverse, and for many technologies and sciences in this process. So I will give a very brief introduction about this Omniverse. So Omniverse is from NVIDIA. So NVIDIA, people probably already know, it's a big company, especially during this this wave of AI, deep learning. They provide GPU, and then they also do lots of like computer vision tasks, like rendering. And recently they launched the Omniverse. And the Omniverse, yeah, this slide is a brief summary of this Omniverse. And it's a platform built for the future. Yeah, multi-layer for multiple audiences. So it's cloud native. It's a multi-GPU enabled. It open standard for cross-team, tool, and workflow collaboration. Yeah, it's for collaboration. It's built on this something called USD, universal. Let me see. I put it here. Universal scene description. So, yeah, some people say from media, they call this USD to the virtual world is something like HTML, HTML for the internet. Yeah, that means it's universal. It will be very essential, very important. So it's scalable, and yeah, it works for all the NVIDIA RTX solutions from laptop to data centers. And there are a component for graphics, for compute, for AI, and there are all kinds of applications like view, like say RecSim is for say robotics. Yeah, there are many applications. So it's a big platform. So in some sense, I view this as the something like for Apple app. So this is say Omniverse is something like the say Apple app to the say mobile computing. Omniverse is something like that in the Metaverse. Oh yeah, so I think that's important too. So that's why I want to talk more about this. And also because I think they have done very good work on simulation and the digital twin. So with this kinds of say simulation capacities, people say from say manufacturer or industry, they can using this kind of tool to help improve their productivity. Yeah, there are also detailed discussions. So I think I will just go very fast since there are yeah, so basically they want to build this tool to solve some existing problems for say collaboration. Yeah, so they build this and they build this for themselves, and then they publish for other people, and they use this universal scene description to unify those diverse tools, applications, and users. Yeah, this USD is important for Omniverse, and so they can connect many things. They can like we said just now, many tools, many applications they can connect, and yeah, so they can power large scale simulations like for yeah, here all these are robotics, but they can also simulate many things. Okay, so this is the enterprise version, and yeah, here are some examples. For example, for BMW, for the factory, manufacturer factory, and for Ericsson for the communication 5G in the city, and for some industrial light and magic. I think this is for game. For the say construction design, and for say future of advertising, and also this is for cars. Yeah, BMW, Volvo, so two car manufacturers. Yeah, this shows that this Omniverse or Metaverse can be helpful for very diverse application areas. So this is like they said, this is the beginning of a Metaverse. They want to do many things for the Metaverse. Yeah, so very brief introduction to refer learning, very introduction to Metaverse, and then I'll talk about some opportunities, especially it's about some successful stories of refer learning. Again, I will go very fast since there are too many content. I was thinking if I should make this more concise, much less slides, but yeah, I don't want to delete many of them, so I keep this one. So I will go very fast. So this is about bandits. Bandits is basically about we have several options. I want to choose one of them. We don't know the underlying utility or real function, but we want to make our decision. So our the reward, the long-term reward will be maximized, or the regret will be minimized. So you can see this is a very abstract model, so it can be applied many places. And this bandit is pretty mature. They are good theory and good applications, and there are people have already applied this to say news recommendation, to say we'll use, say, for example, TikTok. We'll use, say, we'll read some news using your app. There are actually some underlying recommendation techniques, and maybe they are using this bounded problem. And this technique can be also used to other places, especially you have multiple options and you want to choose one of them. And this kind of scenario, this technique can be helpful. Okay, so this is something Microsoft, they are trying to solve. So they propose something to solve some issues they encounter when they try to commercialize this technique. And they have some, they summarize some lessons when they want to deploy this kind of systems. Also there's a blog about refollowing applications at Microsoft. There are actually many inside and outside, and many diverse applications. So that's from Microsoft, and this is from Google. Google have done refollowing for many things. This for neural architecture search. This for, say, data auto augmentation, and this for device placement. For the chip design. Oh no, this is for the say, for example, TensorFlow. We want to optimize the TensorFlow the operation, and this one is for chip design, the chip placement. And they also have done, like industry insertion. Like robotics, they want to put something into something, and using the robotic arms, they do this, and they have achieved very good results for this. And they have make some balloon flying in the fly. And they also have done something like automate the machine learning or refollowing themselves. Something called auto machine learning or auto refollowing. Okay, that's from Google, and this is from Facebook. Facebook is a social media company, so they try to make the recommendation and for example, the streaming, those kind of things, intelligent. So they use refollowing to do that. And this is, I think this is also very good. It's from DiDi. They apply this to the ride hailing order dispatching. This is traditionally this is from operation research. So people study this for a long time, this kind of problem, and they applied refollowing to this, and they achieve very decent results. And this is from some group from ETH, and I think also from South Korea. They train robotics using refollowing, and these robotics can move on very challenging terrain in the field, in the wild. Okay, so there's a summary about how to train robotics. So there are lots of suggestions, summaries, and lessons. So I think, basically, I just want to point this to you. So if you are interested, you can check this out. And also, some discussions about, we are in the big data world, and there are some successful stories, for example, for the GPT-3. And so some people are thinking whether we can apply those kinds of ideas to, like, say, refollowing or robotics in particular. So they are discussing whether we can, take advantage of those progress in big data like GPT-3 to something like robotics or refollowing. So they are doing something like this here. Combinatorial optimization, they are also a good achievement for this. Just now we mentioned this, we talked about this red hailing this parsing. Actually, this is kind of a combinatorial optimization, and so this is more general. And many problems are combinatorial optimization problem. And if we can use machine learning, AI, reinforcement learning to improve the underlying techniques, underlying algorithms, then the operations will be much better, much more efficient. People doing this for game testing, and there are discussions about reinforcement learning for education. There's another example. There's an example about using reinforcement learning for something, like motivation. When we want to learn something, it's better we are motivated to do that. So people are trying to help to improve the motivation for when say people are learning something. Healthcare, and also important issue currently for the COVID-19. There are some works already for this. And AI economics, they are trying to design policies for the government. And there's for electricity distribution systems. Okay, so drug design, that's I think very promising. Although actually some people talking with me, but actually I was aware of this a long time ago. But one issue is actually, yes, as a general discussion, reinforcement learning basically can be applied many places, basically everywhere. But for some applications, for example, drug design, that's not easy or hard for me because the background. So for some application areas, we need maybe domain expert to collaborate. So I think say drug design is some application area for me. If I want to do drug design, I need to collaborate with some domain expert. Since the background is too hard for me to learn fast. Okay, I introduced very fast the opportunities of these successful stories, and next I will talk about some challenges. Yeah, I saw this figure. Actually, there are many challenges, many issues. Basically, from the bottom to the top, basically I put the underlying principles of reinforcement learning, and then the essential element of reinforcement learning, and then the core techniques and the basic algorithms in reinforcement learning, and then those advanced techniques or mechanism for reinforcement learning, and then business and software issues when we want to make say reinforcement learning deployed in the world, and then it's about the application areas. Basically, I say science, engineering, and arts. So basically, that's basically everything that say like the courses in the university. Yeah, there are some issues. This one is something called hidden technical debt. Basically, it's about when we deploy a machine learning system as a software system, there will be some issues, and so people need to study those. The good news is there are some study already for machine learning system, in particular for the supervised learning systems, but not so many for the reinforcement learning system yet. So that's something people need to do for say reinforcement learning systems. What kinds of say technical issues or technical debt? What kind of technical debt there will be, and what kinds of say software engineering issues for reinforcement learning deployment. So yeah, that's yeah. So there are more discussions about software engineering issues for machine learning, and you can see that there are some loops. So that means, so for the normal IT software, there is a pipeline from model requirement to say model monitoring, deployment and monitoring. But for machine learning, there are some loops. For example, when we do model training, we find that, oh, the features are not so good, so we need to go back and do the feature engineering again. Or even when we go to the model monitoring, we found that, oh, maybe we need to collect more data, so we need to go back to the very beginning to collect more data, or even to change the model requirement. So this is a very complex issue. There are some some large feedbacks that make things very complex. Yeah, there are some survey about challenges in deploying machine learning, and some discussion about say something called data cascading issues. Okay, some people discuss the challenges of real-world reinforcement learning, like say limited samples, delays, high-dimensional state and action traces, system constraints, partially observable, multi-objective, real-time, offline, explainable. Yet, so there are people discussing all those things. So that's good. People discuss how to make the robotics learning more efficient, like sample efficient, generalizable, compositional, and incremental. Yeah, this is a big discussion about whether we should take prior knowledge and structure in the machine learning, whether it's a better or better lesson. And Sutton from Alberta, he basically believe that search and learning and meta learning will be very important. But yeah, for sure, there are discussions and debate about this issue. There are say causality. You know, many things we are seeing these days are about association or correlation. It's not about causality. So people need to discuss how to do causality. And representation, how to represent the things, how to represent state model, reward, transition. There are many things in reinforcement learning we need to represent in some better way or even optimal ways. Explainability. You know, we want transparent, we want trust, we want fairness. So for this, to achieve those goals, we need the model to be explainable. So we need to work on this issue. That's important. Neurosymbolic. That's you know, something old, something new. We put them together, and that's something we think may be the future for the AI. Some guideline for reinforcement in healthcare, maybe also interesting for many other things. Yeah, I think I won't talk about details. You know, since I have this, and actually I also write something, some manuscript about things. So I think I'd like also to share those slides. If you email me so I can share those slides. So I put lots of things here, so you can check them out later for the details. So do no harm. That's, I think that's, you know, if you're a doctor, before you become a doctor, you need to take something called the Hippocratic Oath. So maybe for AI practitioners, we also need to take this kind of oath, so we don't do harm. Otherwise, that will be a disaster for the human beings. And there are many constraints. So, for example, for safety. So for safety, we have constraints, and we want the model to be safe. For example, for a car, we don't want the car, especially in the learning phase, we don't want the car just go over to the ditch. So we hope this to be safe. So there are other constraints. Even, you know, for this trust, for say explainability, maybe these are also constraints. So but there are say underlying techniques like constraint MDP. They can help to solve these constraint problems. Okay, so yeah, I think this is a very good talk by Chaba. He talks about myths and misconceptions in reinforcement learning. That's in 2020. You can check this out easily. If you go to his homepage, you can find this. I think this is a very nice talk. Okay, so now I think I want to say something about the reinforcement learning and the relation with other fields. For example, open research, optimal control. And here there are some top experts from open research and optimal control, so they provide some perspective. That's, I think, very helpful for us to understand those issues much better. Yeah, basically, this Dimitri Psakas, he talks about the reinforcement learning and optimal control and say decision control, dynamic programming, those fields. And actually he's pretty positive. He says something like there is a exciting journey ahead, and we can begin to address particular problem of unimaginable difficulty. And yeah, then in this talk he gave 10 key ideas for refining and optimal control. Again, there are too many details, so I'll just go over to So he also talked about the lessons from AlphaZero for optimal model predictive and adaptive control. AlphaGo is basically a discrete problem, but there are some underlying principles. They are also helpful for continuous problems, like in those say optimal control problem. So he has I think he will publish this as a book. It's about 100 pages, and he discussed how to apply those ideas from AlphaZero to optimal control. This is from another professor, Warren Powell, from Princeton. He basically, you can see this. Basically, there are many fields. They are interacting with each other in a very complex way. But basically, this also says that reinforcement learning is related to many those kind of fields. You can see optimal control. You can see, say, stochastic programming. That's something underlying optimal optimization research. Okay, so yeah, there are people talking about the foundations. Let me go over fast. Like say, this is from Risatan. This is very short YouTube. And okay, so there are some discussions about business perspective. So this is for AI or I think it's mainly for super learning, but in some sense, I think it applies to reinforcement learning, although reinforcement learning may have some new features. Basically, it says that there are low gross margin. There are scaling challenges, and there are weaker defensive modes. So AI softwares, they are both software and services. So if it's a service, it's not easy to scale. So that's a problem for AI, say startups or business. So I think this interesting points to check out. And yeah, there are also discussions about from Andrew Yin. He talked about say how to bring AI's proof of concept to production, how to bridge this gap, and also about say ML ops from model centric to data centric. See, yeah, he has some focus on data. Something like he said something like previously people focus on model, try to build better model, but maybe we should shift the gear to data. We should collect better data to, and using maybe the same model can improve the work, improve the performance. And there are several articles discussing about reinforcement learning in the business. They are from one from McKinsey, one from Harvard Business Review. So these are top-notch journals. So I think it's worth reading if you are thinking about reinforcement learning. So they will be applicable. I think basically it says reinforcement learning is very promising. And yeah. Okay, so I discussed many things already. So next I will talk about reinforcement AI and Metaverse briefly. Okay, yeah. So basically I want to say Metaverse depends on AI. That's a very important critical component. And at the same time, Metaverse and country in particular, the Omniverse can provide an excellent testbed for reinforcement and AI. So what reinforcement AI has achieved so far? Actually, we have talked about a lot. Actually, this is about some games results. Basically, there are some say for the games, especially we have superhuman results. This is for AlphaGo. This is for the other games. This is for AlphaGo. This is for many games, reinforcement learning has achieved superhuman performance, and there are many potential applications using those games. And just now we talked about many these kind of successful stories applying reinforcement learning to many applications. And reinforcement learning, games can be everywhere. That's and many things can be gamified. Oh, sorry. This is so what can we do for Metaverse and Omniverse? There are actually many we can do, like say reinforcement AI, computer vision, NLP, VR, AR, MR, ML ops, AI ops, cloud computing, HCI, security, privacy, 5G, blockchain, and there are more. These are more or less underlying techniques, and there are some more concrete techniques, like say digital humans, like NPC, non-player characters, and content generation and game designs. We can improve those techniques and using AI to make Metaverse and Omniverse better. So what can Metaverse and Omniverse do for us? Yeah, just like mentioned, Metaverse will be a great testbed for reinforcement and AI. And reinforcement AI learns a strategy in the virtual world with low cost, and then we can apply this strategy to the reality. Yeah, it's something like, for example, we can have say we can have a car simulation, and then we can train this car in the Metaverse, and then when this is good enough, we can take the strategy in the reality and try it on the real world. So in this process, we can save lots of energy and lots of maybe lives. Just cars will be dangerous if it's not good enough. So in general, this will be helpful for many things: education, research, development, science, technology, engineering, and also recreation, social games. So Metaverse can gamify everything. So if something can be gamified, then we can use AI reinforcement learning to train some good strategy, and then we can go back to the real world, just like we said just now. Okay, so yeah, there will be some discussion about say reinforcement learning AI, Metaverse, Omniverse, simulation, digital twin. Yeah, this is actually a topic in reinforcement learning. It's about model-based reinforcement learning and planning and simulation. So these concepts, they are related, and model basically, the word model. If we know the model, then we can do many things using this model. We can just doing this in simulation in the virtual world. Then we can. It's just like we said that we can using this to find the optimal strategy using the model. And recently there's a long paper. I think it's 80 or some pages. I think that's a good paper if you are interested in this field, simulation. They call simulation intelligence, but anyway, it's about simulation. And then they gave they put those ideas together, and so basically simulation, computer systems, AI, many of those concepts, they put them together and they discuss how to improve the simulation and also improve the AI, and also many fields, say science, technology, engineering, those fields. Yeah, it's a very big survey paper. So again, I think it's interesting to check this out. And nowadays there are many benchmarks. So benchmarks, for example, if we want to do say autonomous driving, we need some benchmarks, we need some simulator, and then it's about algorithm implementation. It's about say this side, the agent environment simulation, and also about performance evaluation. So here I introduce example from again the Omniverse. They apply this to BMW, for the factory, for the Yeah, there are several news about this, and one key point is BMW using Omniverse, they reduced the production planning time by 30%. That's a huge saving for them. And there are some testament from both people, from some high officer from BMW. Basically, they say they are pretty good, and also from Jason Huang from the NVIDIA. Okay, so this basically says they can have a good example using Omniverse for BMW for the car manufacturing. Okay, so data science and software engineering, we discussed that somehow. So, and competitions, there are some competitions. So there are also some good test bed of simulators for, say, yeah, they are related to deep learning and also AI. For example, the first one is about 100 say, kitchen tasks. They collect those 100 kitchen tasks and then they call for the effort to do those well. If we can, if we can how the AI to do those 100 tasks in kitchen, then the AI will be very powerful. And there are also several other platforms for, like, they call this photorealistic and 3D environment, interactive environment to do AI or deep learning. And something called of policy offline deep learning basically is about collecting some big data set and then doing deep learning on that and finding good strategies. Yeah, recently there's a very exciting news. DeepMind apply deep learning to the nuclear fusion. So that's a very important technique for clean energy. They worked on this for 3 years and they made some achievement recently. Yeah. So that's about using deep learning for center cooling. Yeah, for in a Google data center. And this is a game, and it's about racing, so car racing. That's related to, I think, related to autonomous driving, and it's about simulation, but some realistic simulator. So that's something interesting. There are many examples in, say, computer systems, from chip design to the application levels like SQL, and for finance, for, say, autonomous driving. And yeah, there are something about for Omniverse, for Metaverse, there will be something about human in the say Metaverse. So there will be something about psychology. So, and there are people studying like the, say, judgment and decision making, and this is, say, system 1, system 2. That's about some idea in psychology, but people but the author received Nobel Prize in economics, and people in AI are trying to apply those principles in AI. And yeah, this is a concrete example. Apply those techniques in some deep learning algorithms. And yeah, this one is about when we want to design a game automatically using AI. So we need to find some reward function or object function, and then people using something called flow to design this kind of, say, they can design, they can quantify the like fun, like anxiety. To these are the kind of the reward function for how to design a game. So this flow is about psychology of optimal experience, and they use the flow idea to design this kind of fun and anxiety in the game design problem. And there are also something called self-motivation theory, and this is helpful for design the UI, user interface. Yeah, so this one is about recommendation. For recommendation, there are always people involved. So for a good recommendation system, there will be also about psychology, about utility, those kind of ideas. On this one about it's a recent result by GPT by OpenAI. You know, GPT-3. They use human instructions. So I think that's also important, interesting work. So they try to make it align with people's value, human value, and they use something called preference. So human preference are using this preference to design this model. GPT-3 input GPT-3. Okay, this is the discussion, and I see the time is going fast. Yeah, this is something my discussion. I want to say there are AI Infinity, AI X, and AI Zero. AI Infinity needs lots of work, lots of body effort, and current deep learning, like Alex Knight is AI Infinity. And for AI Zero, you know, Alpha Zero, they don't use any human knowledge. They just learning from scratch. That's AI Zero. And many things are AI X. They trying to use simulation using digital twin or using sequential learning. So this is AI X. Okay, so basically, I think we are we are now not so good. Probably we are in this trough of this illusionment. So people, you know, not so much funding comparing with say 2 or 3 years ago, but maybe, you know, we are growing better and better gradually at this moment, I think. So when refining is helpful, I think when big data are available, so it's from maybe from model, from good simulator, or from the interaction. So application will be everywhere. It can solve sequential decision problems, and referral learning can intelligently automate previously manually designed strategies. Okay, so referral learning can be everywhere. That's a figure I used for a long time. Okay. So here is a discussion about why we see so many good stories, successful stories, and referral learning is so promising, but why referral learning is not so widely adopted yet. So this is my attempt to answer this question. So basically, I think one important issue is there are no killer applications yet. For example, for deep learning, there are say face recognition or speech recognition, but for referral learning, there's no such application yet. And so because of this, there's no sufficient appreciation from the say officers or high management, and then there is sufficient resources, and then there is sufficient research and development, and then also slow adoption. So there are actually challenges in education, in research, in development, and in business. But at the same time, there are successful stories. So it's also promising. So you know, we bear in mind there are challenges, but it's also promising. There are opportunities. There are some resources. We organize some workshops on special issue for machine learning in general, and so referral learning is challenging but promising. And yet, actually, this is basically a summary of what I'm talking. I recently upload this on archive, and so if you are interested in topics, if you want a copy of this slides, contact me. Here is my email. Okay, so yes, sorry, I go very fast, but if you have somehow questions, let's discuss. Yeah, thank you.
Okay. All right. Thank you so much for the presentation, Dr. Lee. It's really, you know, so rich information in your presentation, and we can see there are so much, you know, research and studies in your work. So I think I have already received several questions from the audience. Let's see. Okay, one of the question is, Metaverse is just a new concept. while its core is the interaction between virtual and the real world, which is achieved by those technologies like AI, 5G, and AR/VR. Do you agree with this? Why or why not? Yeah, that's the question.
Can you say that again? Sorry, the second part.
Okay, I will say it again. A metaverse is just a new concept, where its core is the interaction between virtual and the real world, which is achieved by those technologies like AI, 5G, and AR/VR. Do you agree with this? Please, talk about the reason why you agree or not.
Yeah. Yeah. Okay. I think I partially agree. Most part. I think Metaverse actually is not new. It's actually it's very old. Yeah, there's a story. There is a novel many years ago. I can't remember exact years, but that's a it's a novel. The term from that many years ago, and actually many concept in Metaverse. So I think that's somehow a buzzword. Many techniques, just like we discussed, like say, like also mentioned in the question, like the like AI, like cloud computing, like AI, VR, AR. These techniques, they have been developed, researched for many years. So so it's a new buzzword, but there are many things have been done for many years, and maybe now a good time for this to go a little bit further. So, and why I want to talk about this topic, I think at this time, deep learning and AI can help each other to make both of them improve faster. Yeah, that's my thesis. Yeah.
Okay, yeah, thank you for the answer. So for myself, I would like to ask a question. Thanks for your presentation. I think this is the first time I heard about like the terminology Omniverse. So could you talk more about Omniverse? What is the difference from Metaverse?
Oh. Yeah, Omniverse. I think basically, that's a product from a media. So I think it's kind of some concrete product of Metaverse. It's from a media. It's from some company. So, I think many things will be same, but they may have their features. For example, why I want to choose this to highlight this Omniverse in this talk. I think they have good support for simulation. They have good support for AI, those kind of things. So I think this is important for like industrial Metaverse. Rather than they also support for like digital human, like social, like games, those kind of things. But I think those are maybe more focused by say Facebook or maybe even Google. But Google may be different. Google, Microsoft, they may be more diverse. But for Omniverse or for NVIDIA, I think one of their focus would be for industrial Metaverse. So I think that's a concrete product for Metaverse. So yeah.
Okay. All right, it's a product name because I'm really curious about this Omniverse. I think it's I thought it's a kind of a concept. So I just Google. It says the Omniverse is a universe that is spatial temporally for four-dimensional. So yeah, that's why I'm asking. Is this a concept or okay? Just what you said is a product. So they are different, right? Omniverse and for that one, I googled on website.
Yeah. I think that's a product. You don't need to think. Maybe this general concept or maybe that's a definition. make some sense. But that's a product. That's a product from company. So yeah.
Okay. All right. I see. Okay. So in case of the reinforcement learning, I think it's a really, advanced and a hot topic, because it's one of 3 basic machine learning techniques, right? Along with the, supervised learning and unsupervised learning. So as you mentioned that Microsoft and Google, both of them have the reinforcement learning technologies, which is applies to their product. So can you explain which company is in the leading place for now, in case to for the reinforcement learning application in their technology?
I think it's hard to say. These are big companies. They are giant companies. They have lots of resources, and they also have lots of good talents, and they put lots of resources on those techniques. So Google is very DeepMind, but DeepMind is a flagship company in reinforcement learning. But Google DeepMind is somehow part of the Alphabet or Google. So if think this way, maybe I will say DeepMind plus Google is kind of leading. But Microsoft or even Facebook, they also have good people there, and it also depends on what aspects. For example, for if you are doing for say social media, maybe Facebook probably is very good. But if you are doing say science, those kind of things, maybe DeepMind now is leading the way. But if you are doing, for example, the say large language models, OpenAI is very good. So these companies like DeepMind, OpenAI, Google, Microsoft, and also like Facebook, DiDi, those companies, they are doing pretty well. On different aspects, they may leading in different ways. Yeah.
Mm-hmm.
Yeah, but if you are thinking about say GDP, if there's a GDP for reinforcement learning, I think Google plus DeepMind is the biggest so far.
All right.
Mm-hmm.
Yeah. So overall, I think the Google
GDP. That's good word.
As you think. Yeah. Okay. You have mentioned, about reinforcement learning, which fast and slow in one of your slides. Could you explain more? Because you go through that slides very fast. I think the audience would be very interested about that. So what goes fast and what goes slow?
Yeah, this is a this is a very big concept actually. This is just like it says that it's a idea in psychology and underlying a Nobel Prize in economics, and people are using that in AI. It's for decision making and judgment. Yeah, like this says that for the system 1, it's about intuitive, fast, unconscious, non-linguistic, habitual. So but for system 2, it's slow, it's logical, it's sequential, linguistic, algorithmic planning. We're thinking about this slow. But for system 1, we do this just intuitively. For example, sometimes when you are driving a car, if you see some accident, you will have something spontaneously. You don't think, you just do something, right? But sometimes when you want to plan a road trip from say Edmonton to Vancouver, you think whether go to Calgary or go to Jasper, or there are only 2 ways, not so many. So, but for some complex things, you need to think them aloud. So that's about system 2. Yeah, and for the learning, they have done something about this. They can learn something slowly, but finally they learn those things slowly. But after they learn those slowly, they can learn something fast. Yeah, so similar to like for human being, in the evolution, we learn something slowly, but finally those things we learn those slowly, they are kind of intuitive. So we can make some decisions very fast in some sense. But there are there are usually this kind of certain one, certain two intuitive or thinking carefully this kind of distinctions between cognition and decision making. Yeah. That's about roughly about this idea.
Okay, I see.
And people apply them to AI and to say decision making. Yeah.
Thank you. Okay, so there's another question is that could you explain more about that slice? When is reinforcement learning useful? That I think you have one slide about that. Reinforcement useful.
Okay.
When is it useful? Yeah.
Okay.
Go more details. Yeah.
Okay. So yeah, for the current reinforcement learning, we are in the big data era. So we need big data, and reinforcement learning is not so sample efficient yet. So reinforcement learning needs big data. So the big data may be from model, maybe from good simulator, or maybe from interaction. So for good model, that's perfect. If you have a perfect model, that's perfect. And say for AlphaGo, for the CombinaTorial, we have the perfect rule. So we have a perfect simulator. Then we can generate data. These data are basically perfect. And for many problems, we have pretty good model. For example, many problems in natural science and engineering, say in combinatorial optimization, in open research, open control, drug design. In many of those problems, we have very good model. So in this case, we can build very good simulator or perfect simulator. So in this case, we can do things pretty good. And I also mentioned the good simulator. So for the natural science and engineering, we can do pretty good simulator. And if we have good simulator, then the strategy we find can roughly easily apply to the real world. Or there are some technique called simulation to reality. We can use some techniques to apply the learned strategy from simulator to the reality. Yeah, so for natural science and engineering, many problems, I think that's relatively easier. But for social science and arts, since they are usually human in place, so humans usually are very complex. They are usually psychology, behavior, these kinds of issues. So sometimes it's not easy to define a real function, to define an object function. So that's very hard for, say, AI for learning. So examples like, say, game design, like evaluation, like education, or like even recommendation. For example, when we are using, say, TikTok, we want to read news. Sometimes we want to, usually, say, we want to read news about, say, arts, about dancing, about theater, about traveling. But suddenly the Russian Ukraine crisis happened. So we want to read news. But how can the app, like, say, TikTok, adapt so quickly? Right? So there are those kind of issues, and sometimes we want the topic to be diversified. So there are many kind of those kind of issues. So we need to find good ways to design the objective. When we have a good objective, we can do say social science and arts better. So just now I mentioned there's something called preference. So human preference. So that's one way to help do this. And other things I mentioned briefly about, say, psychology, say intrinsic motivation, self-determination theory. Those concepts from psychology can help define real function. And then if we have real function, we have object function, then we can do AI, do optimization. Then refining will be helpful. Yeah, that's basically, yeah, if we have big data, and yeah, we have, say, a good real function and good object function, then refining will be helpful. But there will be many cases, many cases, yeah, many cases.
Okay. So I think all of the AI algorithms or machine learning techniques, they are really relies on the data. all things goes to the data issue.
Sure.
Yeah, when the data is enough, then the technology will
So the
be
current, yeah.
okay. So one
Yeah,
last
that's a
question.
big issue actually. Just
Yeah.
so currently it's called big data. Okay, yeah, just one question. Currently it's about big data, but people in AI are still discussing whether big data is the real. Well, big data will be the panacea. It will solve everything. For example, causality or correlation, only data may not be good enough. So the model will be very important. So
Yeah,
yeah,
sure.
I don't know how I organize this talk, but there are really so many topics.
Yeah.
I don't know.
The data
Yeah.
is the most basic one, right? And then based on the data, we build a model, build algorithms.
The current data is the most important.
Yeah.
Yeah.
Okay. Okay. Let's ask the last questions.
Yeah.
Because
Currently,
you.
data is the most feasible solution. Yeah. Okay.
Yeah, I totally agree with that. All right, the last question is just on behalf of myself. You mentioned about the metaverse in this topic. So could you talk a little bit about what is the major challenge to go forward about metaverse, or in someday will the metaverse will confuse the people experience in the life, because they don't know the spatial, they don't know the time, they don't know the space, the past and the future. How would you say about this? Because it's a advanced reality, right? Or the virtual reality. So what is the challenge about this metaverse?
Yeah, so your question is about what the challenges to make metaverse better, or what are the challenges that metaverse may make people confused about reality and virtual? Oh,
Yeah, I
what's
think
your
that
question?
the mainly on the perspective of the human experience. Or in other words, will it make human life worse?
Yeah, I think from
Some kind of feeling. To make people confused.
yeah, I think technology usually are neutral. It depends on how people use it. For example, like the nuclear weapon. Um, so metaverse I think is similar. So I think from the technical part, I think one challenge is in this part I don't talk too much, but I talk it somehow. It's like like for example design the metaverse, how to make it like real, like reality. So I think there are still lots of difficulties doing this. I recently listened to some experts from the VR AR part background. They have lots of good experience, and they say something like, yeah, yeah. From their experience, they say something like if they are using the VR glasses, they feel dizzy after maybe half an hour or 1 hour. So that's a big problem. And so they are still working to improve this. And the expectation is that in 5 years, it's hard for people to just use a VR glass and feel very comfortable. So this is a technical challenge. And I think another challenge, I think a big challenge is just like mentioned, it's not easy to make the virtual reality really reality. There are people can always find the difference. It's so hard for the current technology to make them so real. So that's something people also are working on. Yeah, that's I think open problem for AI, for VR, and for other field. But people are trying to improve on all these aspects. Yeah.
Okay. So can we say for on the perspective of technology, if AI, both of AI and the hardware apply to to the metaverse or apply to the AR or VR, then there's no other issues we need to solve. As long as we can solve everything about AI, everything about hardware, which apply to metaverse. Or in other words, is there any other technologies on the perspective of technology, challenges about technology?
I think we are in the progress to make both AI and Metaverse better and better, but at this time there are lots of challenges, but there are lots of opportunities. I think that's the that's a short answer. I don't know whether that's good enough or not.
Yeah, I know, because this is a really really big topic, and we couldn't predict precisely about this.
So I think we need to. That's also why I put this. I think that's why I put this in this way. Let me see this one. I think we have very big challenges, especially for say this is for reinforcement learning, where reinforcement learning is not widely adopted yet. And in some sense, I think this also maybe for say Metaverse. If Metaverse can be really good, can have some killer application for something, then this cycle doesn't exist. It's just like deep learning in the last several years. There are many funding pouring into the deep learning business, and people working on that, and so many people, so many resources pouring into deep learning. But reinforcement is not there yet, and Metaverse may not be there yet. So that's why I put this figure here. I think that's important for many people to think about it. From the say educator, researcher, developer, and business people. I think that needs all the people to work together to make like reinforcement learning or Metaverse to be like for example, the current mobile computing, right? That needs many people's effort together. Not maybe some company can take at some good time take advantage of this, like say Apple, they have iPhone, but before that, people need to have the technology ready to make those things happen. Just like maybe one or two people, one or two companies may be lucky enough, but before that, all the people, all those aspects need to be input together to make the technology feasible, applicable to those places.
Yeah. Okay. Yeah. I agree. I think Metaverse and machine learning and AI are really interesting field. I think there are many questions, and I think each of your slides we can expanding the discussion, because there are rich information, but we don't have any more time, and I think there's no more questions from the audience. So thank you so much, Dr. Lee, to bring us this very interesting topic, and we hope in the future someday you can come back again to talk about your research and talk about your your progress about this research. All right. Thank you very much, and thank you everyone.
Thank you for the questions. Thank you for the invitation.
All right, thank you everyone in front of the the computer or your cell phone to watch the video, to watch our webinars, and we hope to see you next month. And goodbye, good evening, and have a good day. So let's say bye bye. And what else do you want to say more, Dr.